everyone. I'm glad to welcome you to the PeterPie conference. Today we will talk about using spatial coordinates in Postgres provided by the open source PostgREST extension via PostgREST. This topic combines two aspects. First of all, it is Python development. Of course, we are on a PeterPie. And the second one is the use of databases. This is my favorite topic because I am a developer of the PostgreSQL database management system at Postgres Professional. My name is Ekaterina Sokolova, and today I'm an expert during the upcoming Repet. But the hero is our speaker, Krishna Lodha. Krishna, good evening.
Hi, good evening. Good evening, everyone.
Before we met in real life, real online life, of course, I found your YouTube channel. In my opinion, it's the storage of useful information on development in general and PostgREST in particular. Did you create the channel for work or as a hobby?
Yeah, I mean, I wanted to actually start channel because the industry that I work with, specifically GIS industry, there is not a lot of open source content available. And as you are also part of the open source world, you can understand that for most of the people who wants to do something, the first challenge that they face with open source is the documentation itself. And that's what I thought maybe I can start creating videos to help people like me who in the future wants to start, like learning programming specifically to open source. And that's where I then started creating videos, writing blogs and things like that.
Yeah, thank you for this channel. It contains not only a description of technologies, but also the reasons for use it. And it's really cool.
I'm glad it's helpful to you. I'm really glad. Yes.
Great. And while the audience is tuning in, I remind the listeners that we will see not just a Repet, but a workshop. It will be a real life coding, isn't it?
Yes, I think so. Is it a question for me? I'm sorry.
Yes.
Yeah, it will be live coding, of course, and I expect a lot of people to actually code along with me. Reason being that that's the best way you can actually find errors and get back to me, because programming is nothing if you don't get errors. Yeah, I mean, like that's the whole point. So please try it and don't try to think like, okay, this is perfect and I can just use it in my next project. Please try. Please make sure that whenever you are facing any issues, get back to me or to Ekaterina for a shout out, and I'll try to answer as much as possible. But we are living in 2024, so ChatGPT is also your friend. You can also always ask ChatGPT for the answers as well.
Yeah, that's right. And should our listeners prepare any special programs in advance to complete the tasks or something else?
You don't need it. If you have Docker, that'll save a lot of time in the installation. And personally, that's what I'm going to use in this series. Reason being that I want to cover a lot of topics quickly. But if you don't have Docker, everything that we are doing will still work. It's just that you will probably need a little bit more time in installation and figuring out if all the wires are connected properly. We are going to use a couple of different things. Postgres, of course, which is the main database that we are going to work with, and then PostgREST, which is also an installable thing if you want. But in my case, I'm going to use Docker. And then the last but not least is I'm also using Swagger for better looking API documentation. But again, not something that you need to have. You can also use Postman, which is also something that I'll use. So yeah, in a nutshell, you need PostgREST, and something to actually visualize the API. That's all. And if you don't have that, follow along with me. I have a Docker file which will get everything for you up and running.
Okay, thank you, Krishna. I remind everyone that you can write questions in the chat, English or Russian, and we will definitely discuss it after the Repet. And If necessary, we can voice something during the workshop. It's not a problem. And now it's time to activate the slides. So let's get started.
All right. I'm really excited to share this topic. I actually discovered PostgREST, I think a year back only, while I was actually preparing for one of the other talks in PostgREST conference in Nepal. It was quite cold, but yeah, it was good conference, PG day again. And I found out that PostgREST is one of these things which you need to know because it will allow you to have your own backend ready within couple of minutes. Like so as we move forward, of course, I'll touch more about what is PostgREST. But just a little bit information about what all things we are going to cover in this entire workshop. First is introduction to PostgREST itself. Then we will go ahead up and set up our PostgREST. If you already have a Postgres that you want to use, you might skip some of the steps, but I would recommend not to try on your, like on your data, which is very important to you, because chances are pretty good that we might miss some step and that might be harmful for our database. Then we will use the Postgres into application. And finally, I would wrap it up by introducing PostGIS to Postgres. Now, one of the reasons why I have included PostGIS is because this is the plugin or extension that we use on a daily basis. But one of the core reason why I want to actually do that is because when you actually install PostGIS, it installs bunch of functions on your Postgres. And if you think about it, stored procedures are again nothing but a functions that you ideally would execute from your code. So by introducing PostGIS, I'm also going to show you that how you can write your own functions in PostGIS or let's say Postgres and then execute them as an API. So if you think about it, by using Postgres, we are able to create APIs right out of the bat from our database without having to write even a single line of backend code. A little bit about my company. So there are plenty of fishes in the sea, but why us? We have been providing service for more than 4 years now. It's almost we are finishing half decade anniversary. We are Startup India recognized here in India, so of course, like we are an Indian company. We are open source believers and contributors. We contribute to a lot of open source projects, specifically in geospatial domain. We have clients across all 6 continents and actively looking for the 7th one. So yeah, if you guys have any connection in the 7th continent, please let us know. And we also provide support and training for geospatial. So if you have any specific need in geospatial industry and you either want to know how do we start, or you want to know that okay, we are using these enterprise solutions and how can we move to a more open source solution, again we have answers for you. So we can either reach out to us via website or via email also. Now let's get into the elephant in the room. Introduction. What the heck is Postgres and why you will love it? So back in the days, a stressful day for a backend developer looks something like this. Your all data is housed in a database, and your front end guy is asking you to give him a data in an API format. And that's where you as a backend developer have to write an API. It can be in Rust, it can be in Node, it can be in Python, or maybe in Golang and whatnot. The problem is that it's not just that you have to create a database related APIs which will just take the data and give it to the front end guy. You also have to figure out the authentication. You also have to figure out all the things such as filtering, ordering, pagination, and things like that. So it's never simple to just create simple API, even for a front end guy to test how the data will look like in the front end. And that's exactly what Postgres is trying to solve. So a sleepless night in backend developers looks something like this. Like you have to do strict typing, you have to deal with ORMs, you have to write a dry code, you have to figure out how authorization and authentication will work, you have to follow the standards because ultimately your API should be in, let's say, open API spec. You also have to understand the scalability, that even if a lot of people start using the API, it should scale and it should not like screw the code at any point of time. And most importantly, interoperability. So it doesn't matter if you write your code in Python, if the front end guy is going to use it in let's say React, You will need to tell them that how exactly this will work in fetch API. And again, that comes back to following standards. So all these pieces are very important, even if you have to create a single API for a front-end person to test. And that's where we use PostgreSQL. Reason, first, it is database is a single source of truth. That means whatever data that you have in your database, and I'm not just talking about the business data, I'm also talking about the users, the roles that you have created in database. All of this can be used as a single source of truth. It uses declarative programming, and finally, it's leak-proof abstraction, which means that you don't need to know what is happening under the hood. You will know that when you will connect PostgREST with your database, you will have a list of all the APIs, all CRUD operations of create, retrieve, update, delete, put, everything will be available for each one of the table right in front of you. You don't have to worry about how exactly these CRUD APIs are created for each table. Now, having said that, of course, as a part of authorization, you can always restrict some of the user to do some kinds of things. For example, not everyone should be able to delete or update stuff, but probably everyone should be able to retrieve stuff. So you can manage all this by actually managing the roles in the Postgres itself. So this actually makes your life very easy, because your database administration department, or that person who is managing the database, already knows how to create rules, how to create users, how to actually assign rules to particular tables or to schemas. So the database guy, in short, becomes your backend guy, because everything you're doing has to be done in the database itself. And enough with the chit chat. Now let's actually see how this will look like when you actually go into you actually get your hands dirty. So how exactly it will work when you actually go inside the programming. So as I said, I'll imagine that I have a very fresh computer. There is no Postgres, there is nothing installed, and then we will start from the scratch. Now, all the code that we are going to see in this workshop is already available on GitHub. So, Katerina, can you maybe tell me how can I share this link? Or if you're already on GitHub, maybe you can just search for rotten grapes and using PostGIS in Postgres, or maybe simply using PostGIS.
You can send it for me in our chat, and I will share it in.
Okay. That sounds perfect. Let me put it on the chat. I've sent you on Telegram. So if you do post using PostGIS in PostgREST and maybe GitHub, you'll see a link somewhere which starts with rotten grapes. So you would ideally want to look for this link. It has everything, all the things that we are going to talk about, like setting up Postgres, using PostgREST, and also using PostGIS. So I hope the link will be with you guys. I'll just give a couple of minutes so that everyone has already cloned this in their local computer. So I'll simply copy this and I'll open my terminal. I'll close all the previous terminals and I'll open a new terminal. All right, and I'll make this one a little bit bigger. Okay, so I'll simply go to my desktop and I'll clone my repository over here. Hopefully I don't have same repository available on my desktop, and it looks like I don't. So I have cloned the repository, and I'll also make sure that my Docker is up and running. So as I said, we are going to use Docker, but if you don't want to use Docker, make sure that you have some kind of Postgres running on your machine. And for this particular workshop, I'm also going to use pgadmin. It's just a better way for us to visualize the data in database, and also to see the queries in action. So, I mean, you can obviously use terminal itself to do a lot of PSQL commands, but I'm just going to use pgadmin for the sake of simplicity. I'll also make this one bigger. All right, so my Docker is there, and I've already cloned the repository, and I also have my pgadmin open. So can I get maybe a thumbs up regarding how many people already have all of these things ready so that we can move forward?
Yes, of course.
All right, perfect. So now I'll go inside my repository using PostGIS in Postgres, and I'll simply open it in VS Code. So I'm using VS Code. Feel free to use any other code editor that you like. And in this, I want you guys to focus on the Docker Compose file, because this is where I have made all the arrangements that we will need in this particular workshop. So we start with, first of all, defining our service of PostgREST itself. I'll give it a name as a server, and then there are a bunch of environment variables. For now, I'll just comment these environment variables, and as we need it, we will like just uncomment them one by one. So I'll only keep my Open API server proxy and the database URI. Then I also have I have also created a image for the database, because I don't want to mess up my existing databases. So I'm using Kartoza PostGIS. You can, if you are not that interested into PostGIS extension, you can just use the normal Postgres image as well. Just make sure that you define the database name, the user, and the password, because these will be used in the environment variable for the PostgREST. All right. Then moving forward, as I said, I have also implemented Swagger UI over here. Again, this is purely optional. I've just added this so that even if you want to create a Swagger based documentation for the APIs that we are going to create, you can just have that. Okay, if you don't have pgadmin installed locally, you can also do that via Docker. So you can just go to pgadmin Docker compose, or maybe Docker image, and you will see the pgadmin container image. Since I have that installed on my local, I'm not using that. But again, like if you want pgadmin, you can also get pgadmin available for you via Docker. All right. Now that we have explored what all things are there in our Docker file, it's time for us to actually start the Docker composition. So I'll simply start by doing Docker compose up. Okay, and since I have all of these three images available in my local, you can see that there was no downloading. In your case, it might be the fact that you will need to actually download the image of PostgREST, PostGIS, and Swagger. But in my case, it was fine. So that's why I was able to get everything up and running. Now, if I check in my another terminal for Docker PS, you will see that all three services that we created are up and running. So we have Swagger UI, we have PostgREST, and we have Kartoza PostGIS as well. So everything is up and running. Now, so you can see that PostgREST is actually working at localhost 3000. So what does that mean? That means that if I try to go to localhost 3000, localhost 3000, you'll see that I got something. Even though it says that anonymous access is disabled, at least I got something which tells me that my PostgREST is running. And same thing will happen if I try to go to 8081, which is the port that I am given for Swagger UI. So I can see the Swagger UI getting loaded, but of course it also gives me the same error, that unauthorized request that we are sending. So this will give you clarity that it's not that you can just connect PostgREST with the Postgres database and it will start working, because if you do that, you are essentially exposing all of your data as an API, and ideally that's not correct, right? So if you think about it, whenever in software development, let's say whenever we will work with Python or any kind of programming language, we will have to define the authorization first for all of our APIs. Otherwise, all the data, all the functions that we have, or all the APIs that we have are publicly exposed. And even if you think about it, sometimes we do have things which are publicly exposed, but those are also defined as an anonymous user. So anonymous is also a type of user that we would ideally want to have. And that's what the first step of setting up Postgres with Postgres is all about. So for the sake of simplicity, I am going to use PostgREST when I talk about the software, and PostGIS when I talk about the database, because otherwise it will be too much confusion. So I'll use PostGIS whenever I'm referring to the database. So the first thing that we need to do is we need to fix this error of that we are getting, which talks that it's unauthorized. That means like we cannot do anything. Anonymous access is disabled. So first thing we'll have to do is create some kind of table, right? Because right now we have just generated our PostGIS database, but we have no information in it. And for the sake of saving time, you will find this markdown file in the GitHub where you can actually see that how exactly we will do that. We will create a web anonymous role, we will assign a role to a schema, and we will try to create table and things like that. All right, now let's try to do that. So I have PG admin on my local, and now I will try to connect my database over here. So I'll just put the name as let me just first of all get rid of this. All right, so I'll give the name PyDB. And for the connection detail, I will again refer back to my Docker Compose file. So my port was 5437. So it is localhost 5437. And the database name is mydb. The user is my user. And password is my password. Not the most secure password out there, but it's okay. So now I can save, and there you go. So I have my DB where at the moment we have 3 schemas and we have, I think, no table or maybe few tables. Yeah, so we have this special ref system table, and that's because I have installed the connection, I have installed the extension of Postgres, PostGIS in Postgres. But for the time being, if I show you a couple of rows in this, you will see that we do have data in it. But let's not actually touch this because this is a database that a lot of PostGIS function uses, so we don't want to mess those up. So I'll just create a new table. So I'll go to my GitHub and I'll see what all things we have to do. So the first thing we have to do is create anonymous user. So now this is the user that we would say to PostgREST that use this username whenever no other username or no other authorization is passed. So web anon is that role that will be used when there is no other role defined. So it's kind of like a fallback plan, right? So let's go to SQL tab. Sorry, not SQL tab. Let's go to query tool and just type create role web anon no login. Of course, because we don't want anonymous person to actually have any kind of login information. That's why it's called as anonymous. All right. Now here I have written grant usage on schema fresh, but in this case we are using public schema. So I'll just replace fresh with public. Okay. And now we have grant usage on the schema public to web anon role. And now let's start by creating a simple to-dos table. Okay, a very simple table. It has ID as a primary key, whether the task is done or not as a boolean with a default value as false, then the task itself, and then the due date, that when we are supposed to finish this task. All right, so now our table is created. Now let's try to put some information in that table so that we can visualize it. Now I can simply first of all refresh the table so that refresh the PG admin so that I'll make sure that my table is here. And of course there is nothing in this at the moment. So I'll just simply add some data into it. So let's try with script of insert, and we'll not give any ID, and let's say we'll also not give the done status because of course like when we are creating the task it's going to be false only. So I'll say that prepare presentation. All right, and the due date is 2024-09-16. And the task is inserted. Now let's try to create another task, that is prepare demo GitHub repo. Okay, and this is another task that I have where the due date is, let's say, 10. And now this time let's try to give also the status saying that done, and I'll say that done is true. So true. All right, now we have two tasks. Let's try to see them. So now you can see that we have two tasks with one is false, one is true, one is prepare presentation and one is prepare GitHub repo. And each one of those have their own timestamp with the time zone information. I've kept UTC 0 for the time being, but the timestamp and then the date, whatever we have given till this point. Now it's very important that what kind of access you want to give to this particular table. As an anonymous user, most probably we would want to only give access of visual of just selecting the stuff, right? We don't want anonymous persons to keep posting the data and all. We would want to just give them the select access, and we don't have fresh, we have public. So I'll just simply replicate this, and now the grant for the select on this particular table is given. All right, so at this point, so at this point, what we have done, we have created an anonymous role. We have grant the usage of that role on the public schema. Then we have created a dummy table, and then we have said that as an anonymous user, you can just select. That means you can just retrieve the data from to-dos, and then that's all. You cannot do anything. All right. So we are done with our first setup of PostgreSQL. All right, now we have to let PostgREST know that there is a user or there is a role that PostgREST can actually use to authenticate anonymous requests. And that's what our next environment variable would be. That is PostgREST DB anon role. Okay, and that is where I have given web anon. And the schema is going to be public. So I don't want anything other than public. Now, if you're not using Docker and if you still want to use PostgreSQL, the other thing that you can do is you can actually download PostgreSQL executable file from their from their official website. So you can just go to PostgreSQL, and here you can click on get it running. Let's see why. Okay, yeah. Here you can click on get it running, and then you can just install PostgreSQL. If you're on Mac, you can do brew install. If you're on Linux, there are some other commands, and if you're on Windows, you can just get it. Or the easiest way is that you can get it from their GitHub. So there are all the latest releases available. So you can actually get a zip file, or like if you're on Ubuntu, you can get Arc 64. If you're on Mac, you can get things like that. All right. So for your sake of for the sake of understanding, what will happen is that when you have actually downloaded that PostgreSQL, all right. So in my case, let me download it for a Mac so that I can show you. It's merely 2 MB file. It's not that big. So once you will download it, this will have an executable PostgreSQL. So you can see that this will have an executable PostgreSQL file, and you will need to supply a configuration file. So in case of Docker, we wrote all of our configuration as an environment variable. But in case of in case of executable file, you will not be able to use this Docker based approach or like this environment variable based approach. Other thing that you will have to do is let me actually pull another window where I have this thing ready for you. Using PostgreSQL. So as you can see, when you will start as a fresh file, you will have to actually create a configuration file. That's also given over here. So for example, here is a tutorial.conf. So you'll create a configuration file and you will put all of these information in that configuration file. And then you will do something like this, PostgreSQL and then your configuration. So this will give you the same kind of output because PostgreSQL will actually use all of these environment variables from over here to actually understand that what all things you need, what all things you are passing. Since we are in Docker, we can use this. All right. So now we have defined that, okay, I'm going to use web anon as my anonymous role, and my schema is going to be public. And if you remember, I also kept this PG data in my volume so that my data will be persistent. Whatever role we have created, whatever even whatever tables we have created, everything will be persistent. So now I'll simply stop my Docker Compose file and start it again. Now this is very important that whenever you will make any environment related change in your Postgres, you'll have to stop and you'll have to start it again. Reason being that it has to load all of this environment again so that it will understand what are the latest settings that you want to work with. So I'll simply stop this and I'll make sure that nothing is running now. So if I go to Docker PS, nothing is running, and I'll just do Docker Compose up one more time. Right now, if we go to our Swagger UI, voila, you can see that we have the special refs that we talked about, and there are a lot of functions. As you can see that this is quite a big file. Reason being, these are all functions. So if you remember, I told you earlier that when you actually install PostGIS, it installs thousands and thousands of functions. All of those functions you can see over here. So it has like 1478 functions, and these are all things you can see over here. But at this moment, we don't have to focus on that. If you search for to-dos that we created, you can see that our CRUD operation list for all the to-dos is available for us. Voila. So this is how you can see that we were able to create all the CRUD operation for our database without having to code anything by merely giving the configuration file setting. We were able to get all the CRUD operations. Now let's try to run this, right? So if I try to do execute, you'll see that I got JSON. This is also something that PostgreSQL will do for you. It will arrange your data in a proper format, which is acceptable by whatever programming language that you are using at the end of it. So you can see that we got an array with two JSONs, and each JSON has ID, and ID basically, which was one of our serial key, then the Boolean field done, then the task itself, and then the due date. So that means that you don't, again, if you think about it, when you're writing ORMs or when you're creating schemas, whenever you'll add new column, you'll have to be sure that all of your schemas, all of your tests, everything has also introduced that column in order for you to use it. But in case of this, you don't have to do that. You can just simply add new table. You can just add new column to the table, and that will be available for you to work. Now this is all about getting all the data. What if you want to do filtering? Now this is amazing because PostgREST allows you to also filter the data right out of the bat without having to do anything about it. Let me just actually show you that. Q dot. And yeah, there is query. Yeah, there you go, table and views. So all these things that we can actually do as an SQL query, you can do all of those things using Postgres as well. So for example, what if I want to get all the data where the done status is false? How do I do that? Then you can use eq.false, and then it will only get you all the data which is false. What if I want to get all the data where the query is greater, like the ID is greater than 1, for example? We can just do that. Let's try to see how this will work. And as you can see, with this open API spec documentation, you get all of those parameters available for you. You can do offset, you can do order, you can do limit. So if I just say that, okay, my limit is 1, that means only return one entry, you'll see that I'll only get 1. But if I put offset as 1, that means start from the second one and then only give 1. So all of these things that generally we'll have to actually code in our backend, you have all of these things readily available. Now coming back to what we are trying to do, we are trying to get all the queries, or sorry, all the rows where the ID is greater than 1. So I'll just simply pass gt.1, and it means greater than 1, and now it will return me only that ID. If I do GTE, which means greater than or equals to 1, you'll see that I got 1 and 2 both. Now let's try to do Boolean. I don't know if how it will work, but let's see. If I do eq.true, there you go. It says that true is not the correct statement. So let me try to do true. And there you go. So I messed up. So this is why we want to always have ChatGPT handy with us. And I think you can actually, there is another thing that you can do for Boolean, as much as I am aware of. But yeah, point being, like, this is how you can do it, and not just simple queries like greater than or equal to or something like that, but you can also do queries like in or range or something like and or operator. So you can actually marry multiple queries together and then find out data in between. You can also, I believe, you can also use regex for this particular thing. So this is like really interesting for us to work upon. So here you can see that. So what they have done over here is that age is basically a column name. So they have also used that column name in the query of or operator. So either the age is less than 18 or it is greater than 21. So like they were able to create that SQL query as an as a parameter. And the funny thing is that all of these things are ready for us to available. So again, I'm sorry, I'm stressing on it a lot. But yeah, I mean, like, this is how it is. I think I messed up uh, the I messed up the column itself. It has to be in done. So like now I do eq.true, you can see that I got the true query. And like I can just do similar thing for task. I mean, like I can start, like I can do something like starts with, or the task should contain the name and things like that. So all of these things we can do. Now the next thing is that what if I decide to post a query? So now if I try to do something like id is equal to 4, task is false, and let's keep the task as, trying to add task. All right. And let's keep the due date as 2024 09 19. Now if I execute, it will give me an error that permission denied for the table to do's, and we also get a correct authorization code, unauthorization code, that is 401. So this gives you an idea that this is actually perfect for you to directly integrate it in your existing code base as well, because all the status codes and all the messages are also taken care for. Now, similarly, because if you remember, we only gave access to the select, like grant select to the to-dos and not anything else. And that's why we are not able to do that. So this is how we can set up the anonymous role, and we can also set up all the different tables that we want and get the data from that. So I'll just pause for a bit and wait if there are any questions or if anyone wants to try it out. So we'll have like couple of minutes, like 2 or 3 minutes of break, where if there are any questions, I'll be more than happy to take them before we move to the next topic now. So are there any questions?
No, we haven't questions now.
Okay, I think then we can move forward, I believe, right?
I have my own question.
Sure.
You
Yes.
don't mind? I have a security related question. We discussed being careful with anonymous users, but regular users should not have access to some data either. And sometimes they are selecting from entire tables or views. Sometimes it's about some set of rows or columns. Especially, most users should not be allowed to influence views that will be visible to other users. And I understand the security measures from the database side, but what additional measures should be used from the PostgREST side?
Yes. A very important question, and this is something that almost every time I talk about PostgreSQL, everyone says the same thing. But that's where I actually take them back to this slide, because database is a single source of truth. Postgres itself has no brain. So when it will send the request, it will first of all do the authorization based on whatever setting that you have created in your database. So what do we mean by that? So you can actually create your own JWT authentication token system in your database itself. So it can be, let's say, JWT based, or you might also think that I will have another table where I would like to store username and passwords, and of course these passwords will be hashed. That means in your database you need to have some kind of logic set, maybe like pg hash or something like that, where once you will send the password, it will hash it and then it will store it, and then same thing back. So my point is that you can have a function which is about logging in user, which ideally Postgres will also expose as an API. So you'll have an API as a function where you can, it will be something like, okay, imagine like slash login, where you have to pass username and password. And then once you do that, it will return you back, let's say the JWT token, or maybe if you have multiple hierarchy of login, it might return you the like JWT token, or it might tell you that true or false kind of thing. And then based on this response, your next API can work. So again, point being that you can actually trigger this as a trigger function whenever someone will make a, let's say, select star from to-dos table. So you can actually make that query, check for the username and password first, or check for the role first, and then only execute the query. So again, what I'm trying to stress more on is that you have to imagine that how will you make sure that the authorization and authentication is taken care without even having to think about Postgres. So whatever you will do on Postgres will be exactly what Postgres will use. It will not have its own mind of adding an additional layer of authorization on top of whatever you have.
I also saw a little advice to not use the asterisk, that means select from all.
Yeah.
This avoids risks, unnecessary columns from being included in the view.
Yeah. I completely agree. So
Yeah, thank you.
yeah. All right. So now, building on top of what you asked, maybe it's time for us to actually see that so far we have seen web anonymous user, but what if I want to actually use these APIs for, as you said, like, for posting new stuff, or maybe for deleting, or maybe for updating? How do we go about that? And that's where we have using PostgREST, which is our second uh, markdown file. All right, so PostgREST.org has written a very good documentation regarding what we talked about. So basically, Postgres is designed to keep database at the center of API security. So whatever your database will think is correct, Postgres will think that that's correct, and it will not try to do anything other than that. So one easier way, if you want to manage it internally, is actually you can create the roles like this, like for example authenticator, where that user can actually do the login, and then you can create a JWT token for that authenticator role. So for example, let's say the role is user123. All right, maybe we can actually see it in action. Let me see if we have that as a part of this workshop. All right. So of course we will touch at authentication, but before moving to that, we have already seen the querying, and there is also interesting thing which is known as computed fields. So computed fields are the fields that you want to generate on the fly. So for example, if you see over here, we have a table with the name people, and we have created a function which with the name of full name. Okay, where what we are doing is we are combining the first name and last name. So we can just do that, and inside people we can then run full name as a parameter, which will then return the value. So for example, when you will say that, okay, fts dot Beckett, so Beckett is essentially the last name, then it will look for that, like, which is that last name, which is that full name which ends with Beckett, and then it will return you all of these data from people where the last name is Beckett. And you can, I believe you can yeah, if you and this is again, as you said, that you probably don't want to return all the like you don't want to do asterisk, so that's where you can also pass just few columns that you are interested in, and it will only return you those columns. You don't have to return all the columns. The next thing is ordering. Again, we can say that, okay, I want to do ordering based on what? So I want to do based on ID, or maybe I want to do based on, in our case, it was something like a, so if you see our thing, maybe we can actually do ascending, descending based on the task due date. So I can do something like due date dot ascending, SCE, I believe. Let me just quickly check. I think it's ACE, but let's try descending as well afterwards. Yeah, I think it should be descending. Yeah, there you go. So now we have descending where 16th is on the top and then 10th is on the bottom, like that. So like you can do ordering like that. Then coming to the next one, that's relationship. So Postgres can also understand many to many or one to many relationship. So let's check out the documentation for that over here. Now again, I'm trying to get you back to the documentation because I can obviously add this in my workshop. But when I will actually show you on the documentation, you'll also see a lot of things that we cannot contain in, let's say, 1 hour of workshop, and we need more time for that. So for example, if your entity relationship diagram looks something like this, where you have roles which are connected with actors, which are connected with films are connected with directors, technical specifications, nominations and competitions, then you can have something like this. So here what I'm doing is I want to get data from films, but I also want to get directors ID and their last name. So as you can see over here, we can simply pass that from films, I want to get title, but from my foreign key of directors, I want to return ID and last name. So now you can see that it actually places them very neatly in a dictionary format or a JSON format or object format, whatever you want to say, where you have a title and then director again becomes another dictionary inside which you can have ID and last name. So nothing stops you actually from also having, let's say, this ID married to something else and also returning a dictionary for that, let's say for the last name or something like that. So this is also totally possible. This is one to many, and then again, like if you want to see that, okay, I want to know the directors and then I want to return a list of all the films, and that's exactly what I was talking to you about. So films can again become a list of all the films where the director name is whatever the director names is. So these kinds of many to many and one to many relationships are also possible. Now again, coming back, last thing we would want to touch upon is the response format of how, in what all different formats we can expose the data. And to try out this, I will actually move my query to something like Postman. So I'll just simply copy this and I'll open Postman. And I'll try to run this in Postman. Sorry, I'll just import it in Postman. Also make Postman bigger. And there you go. I'll just remove order for now. And by default, we got our data in application JSON. But what if we want result in some another format? So you can just like do accept text CSV. So for example, we can do text CSV and we'll get the data in text CSV. There you go. So you can also get the data in text CSV format. So just like that, you can also get the data in OpenAPI JSON. And this is one of my favorite, which is getting the data back in GeoJSON format. But of course, like you have to have geometry data in order to return the data in a GeoJSON format. All right. So now moving forward, again, so if there are any questions, please get back to you can get back to Katrina and she'll post it. But for the time being, let's actually move to the third and important step, that is the fourth and important step, that is using PostGIS in PostgREST. Again, my stress is not on PostGIS, but my stress is more on how exactly we can use functions in PostgreSQL. So far we have seen how to deal with databases as tables, but what if functions as well? Because as Katrina asked me the question that how do I log in? So login itself can be one function, or maybe how do I actually create a hashed string based on the password, because we don't necessarily want to store passwords as a raw data. So that hashing and like encryption and decryption can also become a function on their own that you want to execute from wherever you want to do it. So imagine it something like that. You have a backend where you actually use Postgres as your authorization hub. That means Postgres has to authenticate few things which can happen outside database as well. So that is where you can actually create this encryption and decryption function where you can send username and password, and Postgres will tell you whether that is true or whether that's not true. And then you can just refer to those. So that's what we will try to focus in this one. That is PostGIS in Postgres. So now let's go to the third and the final slide, that is using PostGIS. Now, for us to use PostGIS, first thing I would like to do is I would like to add some PostGIS related data into our database. Now to do that, I'll be using QGIS. Again, this is very much geospatial oriented software, so you don't necessarily need to have this. But I'm just adding few data from QGIS to our Postgres database, so that we can see that data live in action. So I'll make a new connection. Okay, there you go. All right, and now I will try to put some data into it. So we have some data available in the GitHub. So I'll just try to use that database. I'll open it in Finder. Just pull that data over here. So I have shapefile of country and I have shapefile of goods. So again, you don't necessarily have to understand what is this data. This is pretty much geospatial related. But as you can see, we have one database which is about all the like all the polygons of all the countries out there, and then we have another which is a point data which looks like all the ports that are available across the world. All right, so I'll just simply rename it as ports, and I'll rename this as countries, and then I'll move both of these data sets into my Postgres. So it'll maybe take like a minute or maybe even less than that. All right, there we go. So now that's the thing that we wanted to do with PostGIS. Now if we go back and if we look at our table, refresh, now we have 4 tables. If I see the data of ports, you will see another type of data that is not generally available in Postgres, that is geometry, and I can click on it and it will show me some of the data set like 100 ports, and you can see that this is actually the data that is out there in a geometry format. So it has geometry attached to it. It's not like a plain data. So how do we define geometry? So the general way of defining geometry is you actually put latitude and longitude to it, right? So now we have created it. If we want to use this data at this moment in Postgres, what we'll have to do? We will actually have to give select access of this data, right? So I'll try to do ports. Run it, and now we have given access of ports. Now let's see if I go back to my Swagger UI and if I simply refresh it, I will have to just restart it again, because again we have made change on the database, not in terms of the table data itself, but in terms of adding new data. So again, like whenever you make change in the database, not on the data side, but on the database side, such as you added new schema or you added a table name, you'll have to restart. Reason being that all of this information is read in the very beginning. Reason being that based on this, your Swagger API documentation is created. So it's not created all the time. It's created when you actually run PostgREST for the first time. So you have to be sure that if you add new table or if you make any adjustment to the roles, you'll have to restart the PostgREST. You don't have to restart the PostGIS or your database, just the PostgREST. All right, now if we try to see, we will have our ports available for us, and there you go. So we have our ports available for us over here. Now what will happen if I try to do, if I try to execute? Let's try to do it in Postman so that we can see it better. So I'll just replace this with ports, and I want application JSON, which is the standard way of seeing stuff. Okay, and there you go. So now you can see that we have a data. I'll just make this one bigger. I think we can do that. Yeah, there you go. So now you can see that we have a data where we have a geometry and it actually contains those latitude and longitude. This is very important because this is generally what you want to see. If I were to like tell you that, okay, your data looks something like this, it will not make any sense to you because this is a blob. It will not make any sense to you. You would ideally want to see your data in much more human readable format like this, where you can actually denote the coordinates in a proper numerical format so that you can use it wherever you want. And this is how you can do it. But this is not the standard format in the geospatial world. In geospatial world, there is a format known as GeoJSON, which looks something like this. So if I go to geojson.io, which is a standard website to create GeoJSON, you can see that when I add a new point, you can see over here, it has to have feature collection, then an array of features, and then each feature will be an object itself. So if I were to add another one, you will see that a new feature is added, inside which we have geometry and then whatever, or like whatever other properties you want. For example, I want to show something like type, which will be road. Okay, if I were to do something like this data will be available in properties, and this is a standard way of showing a geometry data. And now if I want to get this data in proper geometry format, I can just simply pass GeoJSON. So geo plus JSON. And voila, now we have feature collection. So we have all the data that we had in our database as proper GeoJSON format, and that's why we use Postgres a lot in our day-to-day activity, because it understands the geographical data and it actually shows the data in a proper format, which makes it viable tool. Like if we don't use Postgres, for example, we either have to write a query in Postgres or PostGIS, which will actually get the GeoJSON for us, or we'll have to get the data via ORM, like let's say SQL Alchemy or GeoAlchemy or something like that, and then use Python to actually create that GeoJSON. In this case, we have to do nothing. We just have to pass header as accept GeoJSON, and there you go. Your data is available in GeoJSON format. Now, what we want to do is we don't just want to see the data, but what we want to do is we actually want to use these Postgres functions which are ready for us, which are readily available for us. So let me give you a quick demo of how this will work in the PG admin. So if I were to go in query tool, and let's pick up one of the points from Russia, or maybe we'll take the same. Take a location where this is happening. So or maybe just we can pick up any point, to be honest. Let's see if we pick up a very simple point like this. Okay, so we got longitude and latitude, and now we want to find out. So select star from public dot countries where and then we want to do st within. So yeah, let me actually do chat gpt. I don't want to write the entire query. So sql query to do st within based on, so what is the geometry column? Let me quickly check. It's known as geom, based on geometry column as geom, and my longitude is this 94 and my latitude is 57. So we have to do select star from where st within, so it will just give us the query. Yeah, exactly. This is what we want. So I'll just copy it so that I can show you. Maybe just the where clause. I don't want to write. So what we are doing is we are saying st within, where we are creating a point out of the lat long that we have given and the geometry column. And now if I execute it, okay, I have where twice. So now it will run the query and it has given me geometry, and that's exactly what we want, right? So this is a function that is available as a function because we have installed the plugin of ST, like we have installed the plugin of PostgREST. So you can see that we have ST within, STD within, all of these functions. All of these functions are available for us to actually use as an RPC, that means as an API. So how do we do that? We actually, as you can see over here, if you search for st intersect, or let's say st within in our case, so we'll just simply search for st within, and you can see that there will be multiple ones actually, because st within is a function that will also work with the raster data, and we don't want to work with raster data, but we want something like this where I can actually pass geometry 1 and geometry 2. So not this one again, probably this one, or maybe we can just execute this in Postman. So I'll just simply copy this RPC st within. So there you go. I'll go to RPC st within, and I can also read more information about what this function is doing over here. So I'll just have to find st within, and you can see that I can pass two parameters. One is geom1 and one is geom2, and then it will just run that query. So I can do that. But now here, if I want to run this query with the table that is already there, I'll have to actually write a function, because what we can do is we can pass more information. So for example, I can just simply pass, for example, if I were to show you properties, or maybe somewhere where the information about this will be written. Yeah, all right. So because I know, I can just tell you, it is expecting your geometry 1 and geometry 2 in a WKT format. Again, another format that is used in geospatial. But the idea is that if you were to use this function, we can do something like this. Let me copy it so that we can just save the time and I can show you. So you can see what I'm trying to do over here is I'm saying that I want to use st intersect, and I can just simply replace this with st within as well, because we were using within. And I want to say that my geometry 1 is point at 1 1, and then my polygon is 0 0 2 0 2 2 0 2 and 0 0. So you can imagine that we have a square of side 2, and then we are saying that okay, I have a point 1 1, and just tell me whether that is inside that whether that is inside that or not. So I think we'll have to use st intersects only for this one. Intersects. Geometry column is missing. Let me just check. Geometry column is missing. I believe we probably will have to also give access. STSGJSON, geometry column is missing, ST intersects. Probably we'll just restart it again. And we will also see how we can actually create our own functions as well. So like to wrap up the topic, we will also, so this is exactly what we wanted to do. So now we will create a function that will allow us to actually find, like we have to find countries by coordinate. Okay, so I can just give lat long. So just something that we did like a while ago with st within, where we can pass lat long and get the name. So we'll try to do same thing over here. We will write a function where we will pass lat and long as two of the parameters, and it will actually return us the country name. All right. So, and we would want to use the table which is of the name countries, I believe. Yeah. So the name is correct. Name is countries, and we want to do st within, and we would want to use that lat long and usage set geom. All right. So we have our find country by coordinates ready. So I'll just simply run this and I'll restart my PostgREST one more time. Again, because I have created a function, I'll have to restart it because PostgREST will now create a proper OpenAPI spec document for this as well. And now if I go back to my Swagger API documentation one more time, you'll see that my function is available over here and it asks for one latitude and one longitude. So let's now try to use this latitude and longitude that we have over here, right? So I'll copy this and we have first our latitude and then our longitude. And now if we execute, it says that, okay, yeah, that's the problem. We have not given access to our table. So I'll just simply give access to the table. I'm just looking for it's a mess, I don't know why. There you go. So I'll also give access to countries. Execute, and probably now we can actually execute. And there you go. We got the name back. So that was the error that we are facing. And now if we try to do this, probably it's still, yeah. Yeah, there you go. So now we were able to actually create our function and then use it as an API. So just like that, imagine you can actually create multiple functions, whatever you want to do, whatever is your business logic, which can either depend upon your database itself, or it can not depend upon, or it can be a like a simple function that you would want to execute, but it doesn't take anything from database itself. So that is also totally possible. So just like that, we can write our own functions and then use them as an API. That will be also executed. So in this case, we actually created a function which uses database because we were using countries, and then there is another thing that we can do, which is create or replace function that is generating feature collection. All right. So let's also try to execute this. So I'll now again go to my function. I'll actually close this. I don't know why it's like this. Maybe I'll close this one. Yeah. And I'll create a new function. We'll just create new query tool. And what this function is doing is actually it'll ask you to give a table name. That's all. And it will return, it'll ask you to give table name and the geometry column, and it will return your data in a GeoJSON format. So imagine that you don't want to actually, you don't actually want to you don't actually want to use accept header of application slash GeoJSON. You would want to do it on your own for some reason. The reason might be that you don't want to expose all the properties. You might want to just limit few properties, or you might say that, okay, I only want to return a data within a specific region or something like that. So you can just create that. And if you see over here, we are executing a function which is again an SQL function, which will give back the result, and then we will just return that result. So what I want to show you from here is that you can write whatever logic that you want to write in stored procedures, and then you can just run it as a function. Once you create it as a function, you can then expose it as an API, and then your API will start working from Postgres. So this is what I would like to give as my final analogy. So I think, yeah, to be honest, Katrina, that's all we wanted to cover in this workshop. Just an introduction to Postgres, introduction to Postgres as an API provider, and how you can use your own custom functions also in Postgres. So that's all from my end. I think, yeah, as expected, it took like 1 hour 10 minutes, which is what I had planned. And yeah, so that's all from my end. And yeah, if you have any more questions, please let me know.
Krishna, I thank you for this workshop. It was super interactive and full of useful tips. Using PGAdmin allowed us to enjoy live maps and spatial computing in real life. Also, I hope everyone saved the link to the GitHub so they can repeat everything later. And
Please.
and we have a few questions, of course. And first of all, where to implement a connection to a database in an API application?
Sure. So let me give you that answer in two ways. If you are using Docker, then you would give that as a DB URI in an environment like this. And if you're not using Docker, if you want to use the installable, I would say, or executable file, then you have to create a configuration file like this one, tutorial conf like this, and you have to give db URI like this. So it's very simple to understand. Whatever you are giving over here in Docker, it just you add PGRST and then you write everything in capital letters and then replace dash with underscore. So over here, if you want to give, again, JWT secret is a very interesting topic. Unfortunately, we are not covering it this time, but you can actually create a secret token like this, and you can then, for example, in case of environment variable, it will be something like pgrst underscore jwt underscore secret. But if you are using it in your conf file, it will be something like jwt secret. So it will look something like this, and then whatever is your secret, like that. So this is how you can give all the environment variables in the in PostgreSQL. Yeah. So anything else?
Yes. Since we are using API query, we are adding a delay to the request processing. And what are some useful techniques to avoid something like this?
Yeah, that's a good question. See, like as a backend developer, I have gone through that thing where, like, we know that ORMs might slow down the query for some time, and but raw queries are hard to manage. But I mean, yeah, I mean, it's always it's always one of the important thing that how do we speed up the time. But so far we have used, like, we started using PostgreSQL as a demo kind of like an application, but we quickly realized that we can actually use it in production ready. It's been used in a lot of production ready softwares as well. We have actually worked on a project where we had around 200,000 people's, I mean 200,000 users. They were not all concurrent for sure, but it still works fine. So for me, there was nothing apart from taking care of your Postgres database, making sure you have all the indexes, you are doing vacuuming properly, and all the things that you would do ideally to actually execute SQL query fast. If you take care of those things, your application will be super fast. There is nothing you have to do. But having said that, if you still want to make some changes, I would highly recommend you guys to check out Gitter channel of Postgres. People over there are very nice, very active. So there is a Gitter channel available for Postgres as well. Let me just quickly show you that. Postgres, there you go. And yeah, and people over there help a lot. Oh, the only downside that I have felt, that I feel with Postgres is that it's the original Postgres is written in a language that I also don't work upon. So like this is written in Haskell, which is not something I'm really fond of. But having said that, we are at our own attempt to actually create fast. No, not fast API. It's known as I don't remember the name, but actually we are at a stage where actually we are creating our own kind of like a wrapper built in fast API, which will do the job very similar to what PostgreSQL is doing, and it will work on the same principle. You have to give configuration file in the beginning. Once you give the configuration file, it will create that open API spec document, because fast API already knows how to create it. And then this wrapper will be able to actually create the same kind of thing in Python, which makes it much more easy for you to edit and make changes whatever you want. And at the same time, it opens the possibility of connecting a lot of different Python packages with it. So it's not out for public yet. We are still we are spending some time, and of course, having said that, we are always looking for contributors who would want to actually jump into this. So again, it's kind of like a combination of Postgres and fast API, creating like a fast, I would say like fast PG. Oh yeah, that's the name. And now I remember how I got to that name, because it's like it's known as fast PG. Let me just quickly try to search for it. Fast. Yeah, there you go. So this is what we have. And yeah, so as I said, the idea was similar, that we actually added a configuration like this, where you can pass the database related information, and we will actually initiate a fast API documentation, and we will do the raw queries. We'll fetch all the tables that you have, all the views you have, and we will actually expose them as a CRUD API. And yeah, as I said, we are always looking for contributors to this, but we would want to work on the same logic, that database will be a single source of truth. Your authentication, your authorization, everything, database has to take care of everything.
And another question. In custom logic, for example, getting users order or something else supposed to be implemented using procedures, or there are some instruments for such scenarios.
Can you maybe explain a bit, like what do you mean?
I think this is about procedures and how we can use procedures from PostgREST.
PostgREST. Yeah. So that's actually what we did in a sense. Of course, we created functions, and then all the functions and all the stored procedures that you have. So even if you create like a stored procedures, will be exposed as an API. So when you do, so the RPC that you see in this, like, so if you see, everything starts with RPC, which actually which are also all these stored procedures that you have, which will be also exposed as an API. So if they require any kind of input, you'll have to actually think in that direction, that how can I pass that input, because generally that's what we do with all of our spatial related queries, that we will actually try to understand. For example, let's take example of this ST transform. So it will ask you to send geometry, and it will ask you to send from proj as a text, and it will ask you to send to proj as a text. So from here, I can know that I have to pass three parameters. One is geometry, one is from proj, and one is to proj. And then it will do all the transformation or whatever it has to do. So just like that, you'll have to define your procedure. You'll have to write all the parameters into this, and then use it and then you can just use it as a API right away. Same goes with views as well. So even if you have some views, those will be also exposed as an API. Might not be something that you would want. Then in that case, you can just say that, okay, don't give access, any kind of access to this view. So not even a select access, and then those access will be gone.
Okay, thank you very much. And I'm again concerned about security. I believe that in case of using the database from outside, we should plan good test coverage, especially tests with bad cases, including connecting as anonymous PostgREST user or trying to modify tables or views. Please tell me how you plan the test coverage and what are the must-have cases in your opinion?
Okay. Yeah. So I'll just quickly, also encourage you to actually check out this PG auth ID thing. because like this is something that we actually use for SQL user management. So what it will, as I was telling you, we actually have a separate table where we manage all these users, like users username and passwords, or email and password in some cases and all. And then we use extensions like PGJWT, and then we create functions like this, which will either, like for example in this case, it will actually convert your data into, like convert your password into, like as I said, like it can be SHA-256 algorithm or whatever algorithm that you want. So it will actually convert and store that, and then you can just create another function to check the username and password. And at the end, it will actually return you whether that username and password is correct. If it is correct, then which role it has, and then if the role, because once you get the role, then you can actually define whether that. So if you imagine it like this: if you have a role, and if there is a table access given to that role, database itself, when you will pass information about that role, will figure out whether this table from the data from this table should be shown or not. So database is already doing that. So over here, all you're doing is actually returning whether role has to be given to that particular person based on the username and password that that person has used or not. And again, like this is, I believe like this is helpful to you, and this is how like you can also test it on the SQL level. So you can just actually execute the query by passing that username and password, and check whether that is returning the correct token or not. And if it is returning what you're expecting to return it or not. Because again, generally we use things like RESTx or PyTest and all when we want to actually write tests in Python. But again, here the logic is that we have to write everything in database. So all the test cases that you want to do also will become part of the database itself. So that's how you'll have to create those SQL query which will run those tests, and will give you the result what you want or not. Having said that, if you are dead set on creating, let's say, tests in PyTest, then ultimately all of these functions are available to you as an API at the end of the day. And then you can just assert things on those APIs by passing whatever, let's say, parameter like email ID and password, and just asserting. Because what it will do is ultimately it will make call to the database itself. So when we say that select star from public login foo bar, it will actually going to execute this login function with foo and bar, and ultimately it will check whether your login table has the data inside that or not. And then you can just assert that if the token looks something like this, or whether you get token or not. So you can either test it in the database itself, or you can create your own tests outside the database by actually using these APIs. And if you want to see how PostgREST are doing their own tests, then again, I would recommend you to actually check out their GitHub in order to get more information about how they're doing it. And again, because again, as I said, it's written in Haskell and not something that I'm comfortable working with. So I'm not really sure how I can test the PostgREST itself.
Yeah, it sounds like a good tool. Thank you. And do you use CI for such checks for automated testing?
Yeah, the application that I talked to you about, the one where we have more than 200K users, is something that we have started recently, and so far we have not implemented CI. But again, see, my point is that like, what's the use that you want to do of CI over here? If you can just give me a use case.
Just
Because in this case, your CI would just like it'll just refresh the PostgREST, so you have latest configuration available. So even if you make changes in the configuration, or let's say even if you add new role or add new table into your database, you would want to refresh your PostgREST. So in CI, you can just refresh that. Like you can either I'm not sure if there is a GitHub action available for something like this or not, but it's just a matter of fact of refreshing the PostgREST so that it starts again, and it takes the configuration file data from configuration file again, and it loads everything. So probably, I mean, I have not tried it, but maybe something that I'll try.
Okay, I understand. Thank you very much. And at this moment, I invite everyone in our discuss room and suggest to talk about next questions in discuss room. Welcome.